Hi, my name is Lauren, and I'm an environmental biology student at McGill University. This summer, I'm collecting data for my honors research project here at the Canuck Institute. My research project is on bats, and I'm comparing two different methods of acoustic surveys for bats. The first method is using a more traditional handheld device to record the echolocations of bats, and the second way is a newer way that we've developed, which is using a recording device attached to a drone, and we fly the drone at different altitudes to conduct acoustic surveys to study bats. The goal of this research is to determine which method is more efficient when sampling bats in different habitat types. This is important research because bats are facing many threats to their conservation, and finding new, more efficient ways of sampling them can help us understand them better and also protect them better. Let's start by talking about the materials that we'll need to conduct this research. To start off, the drone that I'm using is the DJI Mini 3 Pro. This is a small, light, and quiet drone, which is important because we want the most quiet drone possible to study bats. Next, I have many batteries for the drone. I use the Pro batteries because they last longer, which is important because the drone battery drains quickly since we're carrying weight on it. Next, there's the controller that we're using, which is the RC Pro, also from DJI. Next, we use an iPod Touch with an Echo Meter Touch 2 attached to it as our recording device. We use this both for the handheld method and also for the drone method of acoustic sampling. On the iPod Touch, we use the Wildlife Acoustics app, which is an app that goes hand in hand with the Echo Meter Touch 2 and helps us analyze the bat echolocations. Next, I use an iPhone 11 with the GPS Tracks app. This app helps me map out the transects as I'm walking them when I'm using the handheld method, and it also helps me know when I've walked exactly 100 meters when I'm walking the transects. I also use the DroneLink website on my computer to map out autonomous drone routes. So instead of flying the drone at night when it's difficult to see, I map out the routes on my computer, I test out the routes during the day, and then at night I send off the drone to complete the mission in the dark without having to manually fly the drone. We also have a parcel made of acoustic foam and string. The acoustic foam is there to block the noise of the drone from getting to the recording device. And there's a slit in the acoustic foam that the iPod Touch can fit into so that when we're ready to start sampling with the drone, we can just put the recording device into the acoustic foam. Those are all the materials we need for this research. Let's go batting! The first method of bat sampling is the handheld method. We'll start by connecting the Echo Meter Touch to the iPod Touch, and we'll open the Wildlife Acoustics app and the GPS Tracks app. Once I'm ready to start sampling, I start recording on the Wildlife Acoustics app, and I start a route on the GPS Tracks app, and then I start walking 100 meters. Once GPS Tracks tells me that I've walked 100 meters, I turn around and I repeat this 6 times so that I walk a total of 600 meters. We note the time at the beginning and end of the handheld sampling so that we know which echolocations were recorded during this method. Once the handheld method of sampling bats is completed, we move on to the drone method. To start, we set up the drone, so I unfold it, I attach the string of the parcel to the drone with a knot, and I tape down the ends of the strings to the drone. Once I'm ready to start sampling, I start recording in the Wildlife Acoustics app and I slip the iPod into the parcel. I put down the landing pad on the ground, somewhere where there are no obstructions above, and then I set the drone down on the landing pad with the string hanging out the back, and I set the parcel down behind on the ground. Next, I turn on the drone and the controller. In settings on the controller, I force stop the DJI Fly app so that the DroneLink app will work with the autonomous route. Next, I open the DroneLink app on the controller, I select the route I want, and once I'm ready, I start the route. For each autonomous route, the drone flies a 100-meter transect 6 times, just like in the handheld method. The drone flies at 3 different altitudes for 200 meters each. Before the drone changes altitude, it hovers for 2 minutes. This way we can compare bat sampling with a moving versus a hovering drone. Each time the drone reaches a new altitude or starts hovering, or when it starts and when it ends the route, we note down the time. Once the autonomous route is over, I manually land the drone. Since there's a parcel attached to the drone, it makes it difficult for the drone to go down in altitude. To avoid this issue, I gently swing the parcel side to side as the drone moves down. Afterwards, we sort the audio recordings by sampling method, altitude, and whether it was transect or hover by looking at the time of recording. So that's how I sample bats for my research project. I hope this was helpful.